Hello guys, for today's video we will be doing elements. So what exactly are elements? In my previous video I have explained a little bit of elements to you. Now let me tell you what these are. Elements contain only one kind of atom. So that means elements are particles that consist of the one and only type of atom. Now we have, as a lot of you guys have heard of, the periodic table. The periodic table is actually a list of all the discovered elements found in nature and in lab. In total, there are 180 known elements. 94 of them comes from nature. So there are two parts of a periodic table. The vertical part is called, no, this is the horizontal part, yes. So the horizontal part, or we call it as the row, is known as the group. And this portion, which we call a column, are periods. So there are 18 groups and 7 periods. So 1, 2, 3, 4, 5. Just like this, there are like 18 and 7 boxes where the row is called its group and the column are the periods. Now let's come to another concept, which is compounds and mixers. So what are they? What's the difference? And so on and so forth. But we will be focusing on these two concepts right now. So what is compound and what is a mixture? Speaking of mixture, we all know that when two things are mixed together, right? But according to chemistry, compound means when two atoms, two more than atoms, let's say two elements are bonded together. And what is compound? They are same except for they are not bonded together. That is the only difference. Okay, now we will be talking about atoms. In my previous video, I have mentioned that there were protons, neutrons, and electrons, are mostly singular in all of the cases. The mass is 1, 1, and 0. It has a positive charge, it has no charge, and it is a negative charge. So what does this explain? Well, the proton and neutron neutron number tells you about its mass number, or in other words we can say nucleon number, and the electrons helps determining which element is where in a periodic table. I'm writing as short as PT, periodic table, and how it gives in and takes out charges. I guess you cannot see from here. Yes. So that is about atoms and things. So now you will be asking, how are the electrons really arranged? To understand the arrangement of electrons, we need to know how many electrons are there in an element. So first, we will start off with hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So these are the first 20 elements of the periodic table. So in order to know its position, each of these elements have different electronic configuration, which means the electrons are arranged according to the number of electrons that it has. So the first, let's go with hydrogen. Now hydrogen is a bit weird because it only has one electron. So we can tell this is hydrogen. Now this is not stable at all. You may be asking why. The only reason that it is not stable is because the first shell of any element can hold up to two electrons. So you see there is one. In helium, on the other hand, it has two. That means it is stable and it has fulfilled the number of electrons that is required for the first shell. We call the first shell K, second L, third M, and the list goes on. Because it is like KLMN. It starts with K. Then again, lithium, we have one, two, first one is done, three. Similarly, like that, it goes on. There are number of electrons that are not stable except for the noble gases. You may ask, what are noble gases? Well, noble gases are the gases which have the acquired number of electrons that is required for its shell. So say helium has two, it was required two. Neon will be having 10. 1, 2, 3, 4, 5, 6, 7, 8. The required shell for second, third, and fourth will always be 4. So this, then we have argon, which is 1, 2, 3. So 8 to 10 and 8, 18, which makes argon 18. So far and so forth. Now you will be asking on how do these other ones work, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. You see, these exact unstable elements combine themselves into an atom. Now you might be asking why and how. Well, I'll be giving you an example. For example, magnesium has how many? 12 electrons. And oxygen has only 8. So now If we break down the number of electrons without the diagram according to its shell, it comes as 2, 8, 2. We'll do same with this, which comes as 2, 6. Now look at this very carefully. You see, magnesium, the first shell, the K shell, and the L shell, both of them are very stable. Now, in order to make their third shell, their M shell, stable, you need 6 more electrons. Whereas in oxygen, you have the first shell stable, and the second one requires only 2 more electrons to be shared. Now, logically speaking, which one is better? To give out 6 electrons or to give out 2 electrons? Of course, 2, because 2 is not such a big number and 6 is a huge number. So, a huge number of electrons being, given out is not very helpful. So, what happens is that the 2 electrons of magnesium is accepted by oxygen. So that is why magnesium is known as Mg2 plus and oxygen is O2 minus. Now, these states of elements are called ions. Why are they ions? Because they are charged. This is positively charged and this is negatively charged. Why is this positively charged? Because it gave out the electrons. That's why it is positively charged. And why is it 2 plus? Because it gave out 2 electrons from its outermost shell, which makes it positively charged. Now, why is oxygen negatively charged? Well, the answer is again simple. It received the 2 electrons from magnesium in order to get their octave state. Octave means 8. So they want their octave state to be stable in order to stabilize themselves. So oxygen is negatively charged, and since it acquired 2 electrons, it is 2 minus. Now, as I have mentioned, on the other hand, the noble gases, they usually do not take part in any sort of reaction or any sort of compound breaking or making whatsoever. The reason is also very simple, because you do not need the necessity of getting any sort of electrons or giving out electrons, so which make them almost untouchable. Now let's come to an interesting chapter, or let's say a subtopic of the chapter, which is isotopes. Now, what exactly are isotopes? Now, let me tell you something. Isotopes are actually atoms which have the same number of protons, electrons, but different number of neutrons. Now you might be asking that, oh, so does this, change the electronic configuration or the chemical properties of an atom? No, it does not. Why? Because the number of electrons are staying the same. So since it is staying the same, there is no as of for change in the chemical properties of any element or atom. So in this case, you are safe, because we can tell there are carbon 12, carbon 13, carbon 14, and there is an interesting fact where it says that we breathe in the oxygen, which is oxygen 16. So 16 is that different number of neutron. The actual number, okay, oxygen 16 is actually not the one we breathe then. No, it is my bad. We breathe in the oxygen 14 one. Oxygen 16 one is actually the most abundant gas. Well, if you again ask me, we basically breathe also oxygen 15, but these are the most abundant one in nature. So how we do it is the electron numbers stays here. Again, mind you, electron numbers and proton numbers are the same, just the neutron numbers are different. So oxygen goes by 16, 17, 18, 19, and it goes on. Now, this atom is an isotope. Again, this atom is an isotope, isotope. But the atom is elemental and it is oxygen, there is no doubt. No chemical properties are different in here. Okay, everyone, so that is all for today. If you want to rewatch the video to make clarification, please watch it. And I hope to see you guys on another video. Take care, bye bye.